Hi, today's presentation is for the ICIST conference, and I'm talking about data synchronization between two different cloud software based on web service. I'm Yuan. This presentation is divided into 5 parts. Firstly, I will give a brief introduction and talk about what is data synchronization and why to synchronize the data. Secondly, I'm talking about the related works. Thirdly, I will talk about my implementation. Fourthly, I will give my experiment result. And finally, I will talk about conclusion and what we are going to do in the next steps. Nowadays, cloud computing are more and more popular for small enterprises and teams. They are more convenient and cheaper than buying and installing software on physical servers. There is a variety of choice among different cloud services, like Salesforce or Zoho. However, there may be some situations that we have different projects based on different cloud service but maintain the same data. Each of them may create, update, or delete a record. And though it is convenient to use cloud service, totally migrate one project to another is too costly. As a result, though we use different cloud service, we want to keep the data the same. In traditional software, we can modify the configuration file to enable different software to communicate with the same database. In cloud service, however, there's a little difference. In most cases, cloud software will use their own embodied database. Some of the cloud service, like Salesforce, a platform as a service, allow users to choose their own setting. It allows users to use external data source instead of the embodied database, though it is not an easy work. Some of them, like Zoho, the software as a service, however, don't provide this solution, and we must use its own database. Instead of using the same data source, one choice is each cloud service still use their own database, but when write operation is taken in one of the cloud services, it will send the write operation to the other cloud services to keep all the data same. This is synchronization. Then we talk about the related work. In Zeta's NS research, he provided an idea of data synchronization between two different data sources. When there is a write operation taken in one of the data sources, it first checks if it changed the database. If yes, it will send the same write operation to the other data source. In his plan, a second data source will receive the write operation, modify its own database, and then send the write operation back to the first data source. Since on the first data source, the write operation has already been taken, so there is no more changes. It will stop when no more operations will be taken. We will base on his idea to build our own data synchronization system. To build our own data synchronization system, we also get to learn about the following parts. First is Business Process Model, or BPM. It is the activity of representing processes of an enterprise, so that the current process may be analyzed, improved, and automated. For process automation, it will set special work rules as triggers to start process automatically. It may be used to detect the record changes in database. The other is web service. Web service is a service offered by an electronic device to another electronic device, communicate with each other via the World Wide Web. It is a special function called by users. We can call the web services to write data to the cloud service. Some cloud services like Salesforce enable you to write your own web service, give you more freedom. Some others, like Zoho, just provide some basic web APIs for use, but it is enough. So for our synchronization system, first we set rules to start process when write operations are taken in the first cloud service, and the process will call the second cloud services web service to write the data to the second software. When data operation happen to the second software, so will it synchronize the data to the first software in this way. Then it is our implementation. In Theta's NS idea, when one software receives the write operation from the other software, it will send back the write operation, though the second write operation won't have actual effect. In our case, it will call an extra web service but do nothing. It is a waste of time. We want to avoid the second web service call. So we improve it. We add an extra status field with default value 0. We set the workflows to start the process only when an record is created, deleted, or edited on fields except for the status field. When the process starts, it first checks the value of the status field. If it is 0, it means it is an operation taken by the user but not the synchronization system. It will synchronize the write operation to the other platform, but set the status field as 1 for create or update operation. For delete operation, it will first call the update web service to set the status value as 1, and then send the delete operation. Based on our rules, the status changes will not activate the process. If the status field is 1, however, it means it is a synchronization from the other software, so we will not synchronize the changes. However, for the following changes, based on our rules, modification on the record with status field as 1 will not lead to synchronization. So, if the status field is 1, though we don't synchronize the changes, we set the status field as 0 for insert and update operation, which will not activate the process, and do nothing for the delete operation. So the status field will be 1 only in one synchronization work, and after synchronization it will become 0. In our plan, it will just take one web service call for insert and update operation, and 2 for delete operation, which saves the total web service costs. Then it is the result. We try our experiment on Salesforce and Zoho. We write the workflows and business process. For Salesforce, we write the basic web service for insert, update, and delete. For Zoho, we just use its own web service. First, we try on the experiment without the status field. We insert 10 records on Salesforce, update the 10 records, and then delete them. We repeat the same operations on Zoho, and check how many web service calls are used. For both Salesforce and Zoho, each of them takes 60 web service calls, which means the average web service call for the 60 write operation is 2. Then we try the same operations on the experiment with the status field. For Salesforce and Zoho, each of them takes 40 web service calls, which means the average web service call for the 60 write operation is 1 and 1/3. With status field, it decreases the total web service cost by 1/3. Then we got the conclusion. We implemented a system to synchronize the data changes on 2 different cloud services based on BPM and web service costs, and we decrease the web service cost with a status field. For the next steps, we are going to modify the BPM and web service to make it more efficient. Now for every record changes, it will take separate web service costs. We shall modify the web service and BPM. When the write operations are very frequent in some times, we shall combine multiple record changes in one web service call to decrease the number of total web service calls. Also, we will try to use some external data source for cloud service, like Cloud or MongoDB, which are document-oriented NoSQL database. They are more powerful than database embodied in Salesforce in some situations, and may get better performance. Also, use external data source means we don't need to synchronize the data on our own. That is our presentation. Thank you.